And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and Geeks for Geeks within less than 5 minutes. Okay, so today's problem of the day is decimal equivalent of a binary linked list, which is an easy level problem, but I think it's a bit on a medium level side because yeah, there is some overflow thing which complicates this. So yeah, let's take it as a medium level problem. All right, so let's find out what we have, what we will be given into this problem and what we have to do. Okay, so look, it's very clear from the name only. We will be given a linked list which will be in binary form, and I'm expecting everyone knows what linked list is. So basically, linked list is a collection of nodes where each node has one data which is in the form of integer at present for this linked list, and there's another node next which is pointing to the next node. Okay, all right. So we will be given the head of the linked list, which by which we can traverse the whole linked list. Okay, so one thing is this, and we have to return the decimal value of this linked list, which is representing a number. Okay, so yeah, that is it guys. So basically, if you know what is binary representation, what is decimal representation, let's check this out. So if there is 1000 okay, so it's in binary form. So if I will say what will be it in decimal form, so in decimal form it will be 8. If I'm talking about 101, it will be 3. Okay, so how are we converting this? So what's the thing? So if you will see here into the first example, basically it is 1. We start from the bottom and we will multiply 1 into 2 raised to the power 0, and then this will be 2 raised to the power 1, this will be 2 raised to the power 2. In this way we will increase the power and we will multiply that digit, and I will add all those into my answer and simply return the answer. Okay, so this is how are we going to do this. So as usual, I have written something for you, so let's jump on to the note section for it, where we will think how are we going to solve this. Okay,
All right, so decimal equivalent of binary linked list. Okay, so first thing is we will be converting. So basically, if we summarize this, we have to convert the binary number to the decimal number. So 101, we can represent it to 5. Okay, so this is it. So how are we going to solve this? Look, basically there are two methods. First one is basically the brute force, and it does not have much of the intuition. So first of all, I will convert my linked list 101 into a string. Okay, into a string, and after that, if I will not convert it into a string, we can also get the last digit one by one by modulate by going the modulus of by 10. So I will get the last digit. So that's it. Now after that, I will be taking one answer, and I will be like something like 1 into the last digit, whichever it is, into math dot power of 2 comma that power. Okay, but this function will not work here if I will use the inbuilt math power function. Why it will not work? Because there can be numbers which can be large. Okay, so we have to divide this by 10 raised to the power 7. So in this way, math dot power function will not work. If you can write a recursive function, if you can write a recursive function to calculate the power by calculating the mod, this method will work. But I don't think we should go to this method. Now there's another method. Okay, what can be the new method? So look, the intuitionful method is something like if you know something about the left shift operator, so it's something like 1 is 1. If I do left shift 1 by 1, it means shifting, like multiplying 1 into 2 raised to the power 1. Something like this. Okay. So if I'm shifting 3 by left shift by 1, it means multiplying 3 by 2 raised to the power 1. So 3 into 2, that is 3 into 2 raised to the power 1, that is 6. Okay. So if I will do like how it's working in the backend. So 101. Oh, sorry. If I will do 1, so 3, if I will write 3 in binary, it will be 1 1. So now if I will do left shift by 1, it means adding 1 0 to the right of 1 1. So it will be something like 1 1 and 0. So 1 2 4 6, that is 6. Okay. So in this way, left shift works. And left shift means multiplying that number by 2 raised to the power 1 if I'm left shifting it by 1. So if my number is 1011, how can we convert it to how can we convert this to decimal number? So look, if I will multiply this one by 1, 0, oh, sorry, 0, 1, 2, 3, 2 raised to the power 3, multiply this 0 by 2 raised to the power 2, multiply this one by 2 raised to the power 1, and multiplying this by 2 raised to the power 0. Something like this. Okay, and if I will add this, so it will be my decimal number. How are we going to solve this, guys? So we can solve this by simply, very simple. Look, if I will start from the head of the linked list, I will do something like 1, and after that, when this 0 come, I will left shift this one. I will left shift this one by 1, so it will be like 2. Okay, and then I will add the 0, so it's still 2. Okay, it is still 2. Now again, when this 1 will come, I will again left shift it by 1, and this one will come, I will again left shift it by 1. So if you will see, I have left shifted this one by 3 times. So it is 2 raised to the power 3. And similarly, and I will keep on adding this. So this will be left shifted by once. This will be left shifted twice, but it doesn't mean because it is 0. And this will be left shifted 0 times. Okay. So in this way, I've left shifted means I multiplied it with the power. I think you guys are getting this. And if you will try this with pen and paper, it will be crystal clear to you. Okay. I think that's it. That's it, guys. So these are the steps which you can see. Initialize answer by 0 and the run the loop till head becomes null. Left shift it by 1, which means if I have this 1, so I will add this to the answer, and then the answer will be left shifted 3 times. Okay, answer will be left shifted 3 times. So this 1 will be left shifted 3 times, and this will be left shifted 2 times, this will be left shifted 1 time, and this will be left shifted 0 time. Okay, in this way, and we will keep on adding the head dot data so that the left shifting is included for that, and similar at last we will return the answer. I think the concept will be clear, and I request everyone to please try this with pencil and paper so that it become more clear to you, and please subscribe the channel if you have loved the approach. Now jump onto the code section for it and write the code.
Okay, let's write the code for it. Look, the code is going to be very simple as I've already explained what we are going to do this. So first of all, let's take my answer equal to 0. And after that, I will run a loop till my head is not equal to null. Okay, and simply run a loop. Now what I told, I will first of all do answer left shift by 1. So something like answer left shift by 1. And look, we have to answer modulo 10 raised to the power 9 plus 7. So at every step, I will do something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 raised to the 9 plus 7, something like this. Okay, so this we are going to repeat it so that it doesn't overflow at any point of time. Now after that, very simple, answer equal to answer plus head dot data, and again I will do the modulus. Okay, because I don't want any time it should be going out of the bound, and then it will split. Okay, so something like this, and after that simply update the head. All right, so yeah, let's return the answer here, and that's it, guys. That's it. It's that simple. So I think the problem approach will be clear, the problem statement will be clear, and the solution will be clear as well. The intuition behind it will be clear. So let's simply compile this, and please subscribe the channel, like the video if you have loved the approach, and I hope it get accepted. I'm also solving it for the first time, by the way. That's the issue with me. I don't practice, I simply solve it, and that's why I have to retake videos many times. But I think it should get accepted first time. Yeah, it got accepted by the first time, and I've got my geek bit. Thanks everyone. I'm going to see you again tomorrow. Till then, keep on coding, and bye. And please subscribe the channel as well. Okay.